I just want to go back to my Voyager and Pioneer example for a moment. And I just want to hypothesize and throw this out as a scenario. Imagine that we had pretty much pointed Voyager and Pioneer at Proxima Centauri. And imagine, just bear with me on this, imagine there's a civilization on a planet orbiting that star. And 75,000 years from now, Voyager comes into the atmosphere and crashes. And the government at Proxima Centauri, the military intelligence community, gather it up, as is quite likely, and they say, what the heck's this? And some locals saw it come down, and the government spirits it away to a place, and they start doing some experiments on it, and then all the locals say, hey, we saw a strange object come down and crash. I think it came from another star system. And then the scientists on Proxima Centauri say, no, that's crazy. That would never happen. But actually, it did. I'm just throwing that scenario out there.
Let's take your scenario and explain why it's not going to happen. Because it's really interesting to realize that what's hard to imagine is how big and how empty our galaxy is. Let me give you the likelihood that Voyager or any random probe that's sent out randomly would hit anything is essentially zero. And to put that in perspective, the Andromeda Galaxy is heading right towards us at 100 kilometers per second. Pretty big object. There's 100 billion stars in that galaxy. And so it'll hit the Milky Way galaxy, it'll collide with the Milky Way galaxy in about 5 billion years. Okay? When that happens, the likelihood that any two objects will hit from that galaxy will hit anything in our galaxy, except at the very center of our galaxy, is almost zero. You've got 100 billion stars aiming at our galaxy. The likelihood that anything hits anything else is almost zero because most of our galaxy is empty space. So it's true, that possibility is a wonderful thought. But if you ask what's the likelihood of it, the likelihood is so small that to be essentially zero. That doesn't mean it's impossible, but it means it may be fun to think about, but it isn't happening.
Well, in my scenario, I was saying we deliberately aimed it there.
Okay, that's a different thing.
Yeah.
But if
that was what I meant.
Okay, but then you need to know, of course, where to deliberately aim it. And what we're going to do, and what we try to do, is if we're going to deliberately aim at something, we'll probably aim it at the nearest star system that might have a habitable planet, unless we find a biosignature. And as you say, if we don't find biosignatures in the nearest 100 light years, then you're not talking about 75,000 years, you're talking about a few million years. And, so nothing's impossible, but the likelihood of doing that, rather than, for example, sending a signal, which is much more effective, travels at the speed of light, it's cheap, it's almost free. We could detect a light bulb on Jupiter, on Pluto, if there was one. And so why do that if you're really... If you're convinced there's intelligent life and you're not just interested in probing a potential biosystem, the first thing you'd probably do is send a signal. And so I think sending objects is the last alternative, and in a universe that lasts a long enough time, it could happen eventually. But you're right, it has to be patient, and you have to say the results of this experiment are going to come in after our civilization is long gone, perhaps. So anyway, the point is that I'm not saying any of it's impossible, but you have to think about how plausible it is. And I think if you do that honestly, you say it's less likely than other alternatives.
Yeah, I mean, I come back to the scenario, that what I said about low probability, high impact. And I mean, Michael Shermer, I think, gave an example. I'm sure it's an old saying. I can't remember whether he coined it or somebody else, but he said if you know the one, if you hear hoof prints, hoofs outside your door, think horses, not zebras. And I said, that's fine, and 99.9% of the time it will be horses, but occasionally you read the story about zoo animals escaping, and so it can be a zebra. And so my point with all this is that even if it is low probability, the high impact, the high consequence makes it worth doing. And I mean, I am very pleased that we're having this discussion. I wish more scientists like you would come on board and at least talk about it. And I am glad, I should say, a shout out to Professor Avi Loeb and the Galileo Project.
And Avi was on the Starshot project with me too.
Right. And what I like about Galileo Project, and I think that one of the problems with UFOs and scientists was, for years, people in the UFO community would say, I want more scientists to get involved with this. But the question back, which was a good question, is, well, what kind of scientists? What field?
Yeah.
I mean, who do you want? Do you want aeronautical engineers? Do you want theoretical physicists? Do you want cosmologists? Who do you want? Galileo Project, by having a multidisciplinary approach, is trying to cover all the bases.
And get a lot of publicity, but happily just using private money, because no peer-reviewed government scientific agency would devote money to that, because it's not worth spending public funds on. Moreover, as you know, Avi has achieved a lot of notoriety and I've known Avi for many years, and is a very good scientist who throws a lot of darts out, and anyway, I won't go there. But the point is, as you probably know, the first notoriety was claiming that an object was an extraterrestrial, was evidence of an extraterrestrial civilization, which is just not the case, as other scientists have shown pretty conclusively. But asking the question, could it be, is different than making the claim that it is. And I do worry about making such claims. They get a lot of notoriety, they allow you to write best-selling books and all the rest, but it's not science.
Yeah. I wanted to come back on the government money point, because that's quite important.
Yeah.
After I did the UAP job at the Ministry of Defense, I actually did a financial policy job. And one of the good things about UAP research in government is that a lot of stuff can be done pretty much at no additional cost. Because, of course, a lot of the things you need to research and investigate UAP from within government already exist and already funded. So you are not necessarily having to spend much new money, because what you're doing is piggybacking all the things you need, like, for example, your military radar systems, space fence, the intelligence community imagery analysis, resources and capabilities. All that exists and is funded. So I hope that Congress doesn't say, hey, this is a waste of money, because there's not too much money being spent.
Yeah, but what I want to, you're absolutely right. Because, the military has an infinite budget that spends a lot of money on things that are much less interesting and much less useful. So I have no problem with the military spending or the government spending that kind of money. But you said, why don't more scientists come on board? The point is, the Defense Department has resources to investigate things and use the technology. If you want scientists who are currently doing other projects, take government money to do other things that is much more likely to have positive results, and say, let's take the money from those things and devote it to this, that's a very different thing. That's why you're not seeing many people from the outside scientific community coming in, because they'll all do something that is much more likely to produce something. But the military can devote resources, and I perfectly think should, because for many reasons, but as your department pointed out, for defense reasons. The UAPs are not likely to be extraterrestrial, but it's important from a defensive purpose for an advanced civilization or advanced, technological society like ours to be able to know what is happening in our airspace.